Imagine you're an astronomer. It's 2 in the morning. You've been staring at telescope images for hours. Galaxy after galaxy fills your screen. At this point, they all look the same. Then you notice something strange. A tiny bright dot, just 1 pixel. Normally, that wouldn't be exciting. Computers make mistakes. Telescopes make mistakes. Humans make mistakes. But this dot refuses to disappear. You check another image, still there. Another observation, still there. Now you're curious, because if that tiny dot isn't a mistake, then it might be something impossible. A single star, billions of light years away. Its name is Earendel, and it might be the most unbelievable star ever discovered. To understand why, we need to talk about distance. Space is absurdly large. Light travels nearly 300,000 kilometers every second. That's fast enough to circle Earth more than 7 times in 1 second. Yet even at that speed, light takes more than 4 years to reach the nearest star beyond our Sun. The Milky Way is about 100,000 light years across. Galaxies are separated by millions and billions of light years, which creates one of the strangest facts in astronomy. Looking farther into space means looking farther into the past. A galaxy 1 billion light years away appears 1 billion years younger. A galaxy 10 billion light years away appears 10 billion years younger. The deeper we look, the younger the universe becomes. Eventually, we reach a time known as the cosmic dawn, when the first stars were beginning to form. And that's where Earendel comes from. In 2022, astronomers studying images from the Hubble Space Telescope noticed a tiny point of light hidden inside a distant galaxy. At first, nobody got too excited, because seeing a single star at that distance should be impossible. Imagine standing on one side of Earth and trying to identify a single candle on the other side. That's basically what astronomers were facing. Yet every calculation pointed to the same conclusion. The object was real, a single star. Its light had traveled nearly 13 billion years before reaching Earth. We are seeing Earendel as it existed less than 1 billion years after the Big Bang. Long before Earth existed, long before the Sun existed, long before almost everything familiar to us existed. So, how can we see it? The answer comes from one of Einstein's greatest predictions. Gravity doesn't just pull objects together, it bends space itself. Imagine placing a bowling ball on a stretched rubber sheet. The sheet curves around the ball. Massive objects do something similar to space-time. When light passes through these distortions, its path bends. This effect is called gravitational lensing. Sometimes entire galaxies act like giant cosmic magnifying glasses, and in extremely rare situations, they can magnify a single distant star. That's exactly what happened to Earendel. A massive galaxy cluster happened to sit almost perfectly between Earth and the distant star. The cluster bent and amplified Earendel's light. Without this alignment, the star would be completely invisible. For a brief moment in cosmic history, the universe built a natural telescope powerful enough for us to see something that should have remained hidden forever. But Earendel is more than a distance record. Astronomers believe it may be an enormous blue supergiant star, possibly dozens of times more massive than the Sun. Its surface temperature may exceed 20,000 degrees Celsius. And there is an even more exciting possibility. It may belong to a very ancient generation of stars. The first stars formed from almost pure hydrogen and helium. Heavy elements like carbon, oxygen, silicon, and iron barely existed. Scientists call these primordial objects population 3 stars. No confirmed population 3 star has ever been directly observed. If Earendel is connected to this ancient generation, it could offer a glimpse into a chapter of cosmic history we have never seen before. A messenger from the beginning of time. To investigate further, astronomers turn to the most powerful space telescope ever built, the James Webb Space Telescope. Unlike Hubble, Webb specializes in infrared light. As the universe expands, ancient light becomes stretched into infrared wavelengths. Webb is designed specifically to study this ancient light. Its observations confirm that Earendel is extraordinarily distant and helped scientists learn more about the environment surrounding it. Each new observation brings us closer to understanding how the first stars formed, and perhaps more importantly, Earendel suggests there may be many more stars like it waiting to be discovered. Hidden for billions of years, their light only now reaching Earth. Earendel is more than a record-breaking star. It is a message, a beam of light that began its journey nearly 13 billion years ago. For almost the entire history of the universe, that light traveled through expanding space, crossing unimaginable distances, passing galaxies, clusters, and cosmic voids, until finally it arrived here, on a small planet orbiting an ordinary star. And for a brief moment, we looked back across nearly all of cosmic history. Earendel reminds us that the universe is still full of surprises, that even now there are discoveries waiting beyond the edge of what we think is possible. And somewhere out there, hidden in the darkness, there may be other stars that shouldn't exist. Yet somehow, they do.